In our vector calculus class today, I will be teaching you the algebra of vectors. When we talk about the algebra of vectors, just like we know, it's just about the simple arithmetics that we carry out on vectors. These arithmetics include addition, subtraction, multiplication. And should I also mention division? Maybe partially, not fully. Partially because we can divide a vector by a scalar, but we cannot divide a vector by a vector. Once again, we cannot divide a vector by another vector. We cannot do that. But you can add two or more vectors, you can subtract two or more vectors, we can also multiply two or more vectors, as the case may be. Now, we are going to consider certain rules, alright? These rules are algebra rules, according to Euclidean geometry. These rules of arithmetics applies to the concept of addition and subtraction of vectors. And what are these rules? One of them we're going to talk about the commutative rule of vector addition and subtraction. What do we mean by the commutative rule of vector addition and subtraction? If I give you v plus w, these are vectors, is the same as w plus v. So the order of arrangement of vector addition does not matter. Is that okay? And now we're also going to look at associative law or rule of vector. What is this law all about? If I give you u plus open bracket v plus w, close your bracket, it is the same as proceeding to do u plus v in brackets, then plus w. Next, we're also going to consider another law which will guide what we're going to deal with when talking about addition and subtraction of vectors. We're going to look at distributive law. And what is this distributive law about? If I give you something like u, open bracket, v plus w, close the bracket, it is the same as u multiplied by v plus u multiplied by w. We refer to that as distributive law. We are using u, v, w as vectors. Is that okay? Then again, also, we are going to consider another form of distributive law whereby we shall use a scalar, which is a number, to multiply vectors that are either being added or subtracted. For example, if I give you k, open bracket, u plus v, close your bracket, that is simply equal to k times u plus k times v. So you see that we've been able to distribute a scalar k over u and v. Please take note of this, the concept of additive inverse of vectors. If you're given vector v plus open bracket minus that same vector v, you are going to get 0. That is the additive inverse of a vector. And of course, we're also going to talk about the addition identity of vectors, where if we add a vector to 0, we are going to get that vector itself, which simply means 0 plus, say, vector u is still equal to vector u plus 0. And that would produce that same vector for us. So these are basic rules we are going to apply when we are treating addition and subtraction of vectors. Then we'll also talk about multiplication of vectors. We're going to learn the scalar or dot multiplication method of vectors. We're also going to consider the cross, also known as vector product of vectors. Remember, you don't divide a vector by another vector. From our previous class, we already introduced the concept of our specific unit vectors, which helps us to add, the component of a vector. And so we're going to use those specific unit vectors to guide us in terms of like terms when we carry out addition and subtraction of like terms. We shall be studying straight on with addition of vectors. We now want to look at our very first question under algebra of vectors. We are going to consider addition and subtraction of vectors. So here we've got our very first question. Let vector v be equal to -1, 5, -2, and vector w equal to 3, 1, 1. It is required that we find these terms. Is that okay? We're going to take this question one after the other, starting with the A part of this question. In A part of this question 1, we are asked to find v minus w. All we have to do is to identify vector v and vector w, then we subtract them. That's going to give us vector v from the question is this component that we have here, which of course is -1, 5, -2. And so I'm going to indicate my minus sign here. W is 311. Good. Now we're going to carry out the subtraction, and the way we subtract is simply following their like terms. And what do we mean by their like terms? Alright? You know already that in terms of specific unit vectors, we can actually introduce our ijk here. This is -1 times I, which is simply minus I. This is 5j. This is minus 2k. This is going to give us 3i. That's 3i. This one j, and this is what? K. So in terms of the like terms, I component from here to I component in the other vector, j to j, and k to k. Quite simple. Is that okay? So that's why we say that they follow a normal algebra rule. Is that okay? So this is simply going to be equal to, I would bring out -1 from here, the I component, then -3. -1 minus 3. Alright, so comma. I just want to show you the full working, and that's why I'm doing this. -1 minus 3 here. That will be our first component, the I component of our result. Comma, then the next will be 5, and then -1. This is going to be the j component. Is that okay? And then the next is going to be -2, and then -1. Correct. So you see how I've picked their like terms. So that's just what you do when treating addition and subtraction of vectors. What is left for us is just to simplify. This x value, which has the direction vector I, if you work it out, you're going to get -4. This is going to give us 4. This -2 minus 1 will give us -3. So this is actually the value of v minus w. If you don't want to leave it like this, you can introduce your specific unit vector or specific direction vector ijk. This is -4i. That gives you room to add plus 4j, then plus -3k, which is simply -3k. So any one of these is our answer. We are done with the A part of this question. Before I move on to B part, I also want to emphasize that this thing you've just done here is simply the same as calculating maybe the vector known as wv. V minus u is simply the same as obtain the value of vector wv. Alright, wv, which means a movement from w to point v. Point v will be the final value, so it's just a final minus initial. Okay, so having explained this concept, we're going to move on straight on to the second part of the question, B part, and I'll be fast in that. We are asked to evaluate v plus w, and so I'll be fast in doing that. We know our vector v already, the component -1, 5, -2, then the next one, w, is 3, 1, 1. We are adding, you know that. Correct, so adding up this in terms of the like terms, xx, yy, zz, okay? Or you talk in terms of I to I component, j to j component, and then k to k component. So doing this, -1 plus 3 will give us 2. Then the next 5 plus 1 will give us 6. And then the next -2 plus 1 will give us -1. And of course, this is the value of v plus w. You may choose to write it with your specific unit vector value. So I can say this r 2I plus 6j minus k. So any one of these is the value of this problem. B part of the question. Then C part, we are asked to evaluate minus 2v plus 4w. Minus 2v plus 4w. How do we solve this? Now observe that in this case we are not using a scalar to multiply the vector v and then another scalar to multiply the vector w. And like we said by the algebra rule, if you are using a scalar, because this is minus to a number, are you following, to multiply a vector, then that number, that scalar will multiply each terms of the vector. That's what happens. So I'm going to write this as minus 2 open bracket our v. We have this. Then we are adding it to 4 times the value of w, which is, and so we're going to use this minus 2 to multiply each of the term in v, use plus 4 to multiply each of the term in w, then we just add. If you do that, this is going to give us minus 2 times this will give us 2, minus 2 times 5 will give us minus 10, minus 2 times minus 2 will give us plus 4, that's positive 4. Add up to 4 times 3 will give us 12, then 4, because 4 times 1 and then times 1. If you add up this, 2 plus 12, you're not going in terms of like terms now. 2 plus 12 will give us 14, minus 10 plus 4 will give us minus 6, 4 plus 4 will give us 8. So this is our answer, or in terms of the specific unit vector, this is going to give us 14i minus 6j plus 8k. So any one of these is the answer to C part. Then D part, I'm going to manage this space, so I'll just go straight out. We are solving v minus 2w. So vector w is being multiplied by a scalar, minus 2. So of course, this is going to give us v minus 2w. So this is equal to the value of our v, we have it already, that's this. So we are subtracting 2 times w from it. So we're going to use 2 to multiply the component of w. And the component of w is 311 given to us in the question. So this is going to be minus, open bracket. Now, I'm going to use the 2 to multiply directly. We don't have enough space here to show all the workings. 2 times 3, because w, 311, it's going to give us 6. Then 2 times 1, 2 times 1 again, will give us 2, 2. And so we cannot go along by adding or subtracting like terms here, because this is subtraction. Minus 1 minus 6 will give us minus 7. And then 5 minus 2 will give us 3. Minus 2 minus 2 will give us minus 4. So we've got this as our answer, or in terms of the specific unit vector, minus 7i added to 3j, and then minus 4k. So any one of these two is the answer of the D part of question 1. So say that adding or subtracting vectors is a straightforward concept. There's nothing difficult about that. Alright, we shall move on to our second question on addition and subtraction of vectors. In our second question, we are given the vectors v equal to minus 1, 5, minus 2, and w equal to 3, 1, 1. Same like the vectors that we had in question number 1, right? Okay, now let us see what we are asked to find. The I part of the question, we are to find the vector u such that u plus v plus w is equal to I. Let's deal with that first before we move on to the I part of question number 2. Alright, so we are looking for vector u, we don't know. But we're given a condition under which we are to find vector u. That's the interesting thing about this I part of question 2. The condition under which we are to find u is that u plus v plus w equal to what? I. Alright, so we know that u plus v plus w is equal to I. So all I have to do, like we said, addition and subtraction of vectors generally follow Euclidean principles. Is that okay? Simple geometric rules. So you can refer to it, algebra laws. All I have to do here is substitute the value of vector v and vector w, which were given to me from the questions. But because this is equal to a unit vector I, it simply means that I would have to deal with this guy in terms of their specific unit vectors. This will be minus I plus 5j minus 2k. This will be 3I plus j plus k. Are you following, right? And then solve. Or, if I want to maintain these components, then I would come to this I would not use this I. Rather, I will extract the coefficient, which is 1. Are you following, right? Which therefore means that this is going to be the value of u, which I don't know, that's what I'm looking for, okay, plus the value of v, plus the value of w, then I'll make it equal to 1 instead. Alright? But just for us to be fair, I would like to leave that I and then deal with v and w in terms of its specific unit vectors. So let us do that and see. This is going to give us u, we don't know, that's what we're looking for. Then plus the value of this v was given to us in the question. This is minus 1. That minus 1 is simply minus I. So I'm going to write for v minus I. Alright. And then we have plus 5j. And then minus 2k. I'm going to add it to the value of w written to include a specific unit vector. So we've got 3I plus j plus k. This will be equal to the unit vector I. And so all I have to do is just normal collection of like terms, making u subject of the formula. To do that, this is going to give us u equal to, now I want to move these terms to the right hand side now. The right hand side we have I. Let me just pick these whole terms to the right hand side. And these whole terms to the right hand side. So I'll simply be changing this sign, plus. If plus crosses the equality sign, it changes to minus. If this plus, this term crosses, it becomes minus. Good. Remember, this I is the term, the unit vector on the right hand side, which we are collecting these other terms to meet. So the vector u will now be, let's work on this and see, we are going to add or subtract this as the case might be, following their like terms. You can see the ijk component already. So we go I minus I. And then we'll come over here, minus 3I. Are you following, right? We're working with the I components already. So let us do that and see. This is going to give us I minus this will give us plus I. Then coming over to this, we have minus 3I. So this is the first term we've got there, plus I'll now deal with the j component. This is minus times plus 5j, which of course becomes minus 5j. Minus 5j. And then I'll come over to this and pick the j component. Okay, and so minus times this j will give us minus j. And then next, I am going to deal with the k component. You notice that only the I component has 3 terms because we had one I originally given from the question. Is that okay? So let us move on to the k component and see. Here we have minus times minus 2k plus, which is going to give us plus 2k. Minus plus. Then come over here, you pick the k term as well too. Minus times plus k will give us minus k. I think that's all. Simplifying, the vector u will now be, if you simplify this term, I plus I is 2I minus 3I will give us minus I. Now coming to this is minus 5j minus j. This bracket will produce minus 6j for us. So plus times minus 6j will give us minus 6j. Now coming over to this, 2k minus k will give us k. And there is positive outside, so it's still positive k. So I have plus k. And so this is our answer, or in terms of component forms, alright? If you don't want to show the ijk, you just have to extract the coefficient of this ijk and then enclose them in bracket. Here we have minus 1, and then this gives us minus 6, and for this k we have plus 1. And of course this is an alternative way you can write this answer. So the vector u we are asked to find, that's the value there. So you can see how I solved it, just simple arithmetic. Is that okay? Then considering the like terms using the ijk unit vectors. Let us now move on to the second part of our question. We are again required to find the vector u such that this condition holds. So this I part of the question, u, again, we don't know. Subject to the condition that u plus v plus w is equal to 2j plus k. And so we're going to do our usual substitution for v and for w, which we have in the question, and then we will solve and obtain the value of u. Now this is what I want to do in this question, so that you will see that in either ways you will still get your correct answer, whether you solve using the ijk specific unit vectors, or you choose to use the component, the scalar component of the vectors, you still get the same answer. Alright, now let us move on. U, I don't know the value, so I'm going to write u plus w, okay, plus v. What is our v? If you look at it, these are the scalar component of v. So I'm going to maintain it. I wouldn't change anything to, okay, I wouldn't introduce any ijk there. So it means I'm going to have minus 1, 5, and minus 2. Add it to w, and of course w is 311. This will now be equal to, now watch, instead of dealing with 2j plus k, I'm dealing with scalar component already, so the specific unit vector, I'll just keep them aside. It's still the same thing as what I did here. Remember, I made reference to that. I said something like that when I was solving this I part, that I can choose to solve in terms of scalar component. In that case, instead of this I, I'll simply pull out the coefficient, which is 1 there. So in this case, the coefficient of j is 2. Take note, there is no I term here. The I component is 0. So that 0 times I will give you 0, it goes off. That's why we don't have it there. So if I want to show that of the I can simply say 0, comma, are you following right? But I don't want to do that. Let's just maintain that the I term there is 0. So this will give us 2, comma, then the coefficient of this case is what? 1. Is that okay? And so all I have to do is now to collect like terms and simplify, solve for u. And I think this is quite interesting, because you know, this question given to you, one could have just given you this line straight on like this and then asked you to find u, the vector u, instead of just using the unit vectors there. They might just choose to pick the scalar component. So it's important that I did this, alright? Now u will now be equal to, I'm collecting like terms, so this is going to be 2, 1. Remember that x there is 0. Then if this term moves, this plus is going to change to minus, and then the w term will also move. This plus changes to what? Minus, the right side of the equation, then 3, 1, 1. So we're going to deal with this, considering their like terms. For the x term, the x here is 0, you know that. So 0 minus is plus. So 0 plus 1 will give us plus, then plus 1, then minus 3. So eventually we're having 1 minus 3. And 1 minus 3 will give us minus 2. Good. That's the x term. And then this term you're seeing here is your j term. I think I have to introduce that 0 for x. Okay, that's the I component. I just discovered something which may get you into trouble, having just a note on this. Are you getting me? Because one may think that this is the I coefficient and then this is the j coefficient. Okay, so please permit me to do something here. I'm going to write 0, 2, 1. Good. This is clear already. And so I also do that here, so that once you have this, you would know that the x term is actually 0. If I don't put the 0 there, ordinarily, if someone comes to, let's assume you have a note or a textbook, no audio or a video concept there, we might wrongly think that this is x. Are you following, right? So that's why I just had to introduce it. Alright, so let's move on. Coming to the y term, this is 2, then minus 5. 2 minus 5 is going to give us minus 3. So have minus 3 from here, and then minus 1. Minus 3 minus 1 will give us minus 4. Okay, then finally the z term. Is that okay? That's the k component of the unit vector. From here we have 1. Minus 2 give us plus 2. 1 plus 2 is 3. Then here we have minus 1. So 3 minus 1 is going to give us 2. And so this is the value of our u. Or if you now want to write your answer in terms of the unit vectors, then this is going to be minus 2i minus 4j plus 2k. Good. And so we are done with 2II question. We shall be moving on to the third part of the question, where we are required, to find a scalar n such that n times this vector will be equal to k. We have to obtain the scalar n. On a given condition, I'm going to manage this space because, of course, from here, I don't think I have anything to solve. Just to show you why I don't have anything to solve. That k is unit vector k, you know that. For us to calculate the value of n is multiplying this term already. You know that this whole term is a vector, is that not so? This is a vector, we have the values there. I believe that if I ask to find v plus 2w, at least from question number 1, you can solve that. If you do that, this bracket will give you a vector. So this is just like n times that vector equal to k. So making n subject to the formula, in this case you divide both sides by the coefficient of the scalar n. So this is k all over, we've got v plus 2w. Now, like I said, this is vector divided by vector, not possible. In fact, let me write, does not exist. So n does not exist. And what is the reason? You cannot divide a vector by another vector. This k you're seeing here is specific unit vector k. It has z value there, which is positive 1, the quotient of this k. This v plus 2w is also what? A vector. I've stated from the outset of this class that you cannot divide a vector by a vector. That is why n does not exist. Let us take our third question, which of course is going to be the last question in addition and subtraction of vectors. So let us see what we've got in question number 3. Consider the vectors PQ and RS in 3 dimensions, that's vectors in Euclidean space, where P equal to 215, Q equal to 357, R equal to 1 minus 3 minus 2, and of course, we've got S equal to 210. Now, it is required that we obtain A, the modulus, the magnitude, the length of vector PQ. Remember these 3 terms that I've used. Modulus, magnitude, length, they're the same thing. Then B, we are required to obtain a unit vector in the direction of the vector 1 over 2 RS. So let's see how we deal with this question. Remember, we are still talking about addition and subtraction of vectors. It's just that this question now extended it a bit to what we had treated in our previous class, determining the modulus and of course a unit vector. But we're interested so much with this concept of PQ and vector RS, because to obtain this, it's simply doing Q minus P. That's equal to vector PQ. Straight on to the first part of the question. To calculate the magnitude of vector PQ, we first have to know the value of that vector PQ. Are you following right? As in the vector represented by PQ. Remember, P is a point defined by this coordinate, and Q is a point defined by this coordinate. So it's just like moving from point P to point Q. Q is the final point, P the initial point. So to obtain the vector represented by PQ, it's going to be OQ then minus OP. Please take note that this concept of OQ and OP, I think from my introductory class of vectors in Euclidean plane and space, I explained that that O is taken as origin. Okay, so the coordinate of that point O is 0, 0, 0 for 3 dimensions, and simply 0, 0 for 2 dimensions. So here, since P and Q are in 3 dimensions, that point O is also 0, 0, 0, 3 dimensions. But we don't usually introduce that concept of 0, 0, 0, and then linking it to point Q, which has been given to us as 3, 5, and 7. Because even if we do that, OQ is like Q minus O. And Q, we have 3, 5, 7. O, 0, 0, 0. Even if you do that, it will still give you this value, 3, 5, 7. I just had to introduce this O concept for standard. In case you see that anywhere, alright, it's still simply the same as Q minus P. Alright, so let us substitute here and see what we are going to get. Vector Q is 357, so OQ is actually 35,7, then minus vector OP, which is simply point P, and that is 215. We shall do this subtraction, and of course, you've been drilled very well from question 1 and 2 on how to carry out subtraction of vectors. So this vector PQ is actually equal to 3 minus 2, you get 1. Then 5 minus 1, you get 4. And then 7 minus 5 will give us 2. Good. This is the value of the vector PQ. If you want to write it in the specific unit vector form, this is I plus 4j minus plus 2k. Alright. Now, what we are asked to find in question A is the magnitude of this vector represented as PQ. We already know vector PQ, any one of these. So to get the magnitude of vector PQ, right, I've decided to use single slash. I commit no crime. Is that okay? You know the magnitude formula, the modulus formula. We just need to rely on Pythagoras theorem. And so we can substitute here to see what this is going to give to us. Magnitude of vector PQ will now be equal to, the x value is 1, and then y value is 4, z value is 2. So just square each of them and add. Working this out, this is going to give us 1 plus 16, you get 17, plus 4, you get 21. So this is root 21. Can we break down that 21? I don't think so. There is no perfect square greater than 1, which is inside 21. Alright, so we can't break that further. We are done with the first part of our question. Let's move on to the B part. In the B part, we are to determine the unit vector in the direction of this vector. Now, how do we obtain unit vector? We know the formula of unit vector of any vector to be that vector divided by magnitude of that vector. Is that okay? So, if we are to obtain the unit vector in the direction of this, you notice that this vector RS has been multiplied by 1 over 2. So, what we're going to do is simply get to know the vector represented by RS, divided by 2. And then, what we are going to get will be the vector whose unit vector we are to calculate. So, we shall proceed to obtain 1 over 2 vector RS first. And to do that, that's simply 1 over 2 multiplied by vector RS is simply S minus R, which is OS minus OR. Are you following, right? I've shown that in the first part of the question, so I wouldn't want to bother ourselves in introducing the O concept. That's the origin. So I'll simply just say S minus point R. But take note, this is OS minus what? OR. If we work in this, we are going to get 1 over 2 point S from the question. Let's see, 210, that's the coordinate, and then point R, the coordinate given in the question is 1 minus 3 minus 2. We are going to carry out this subtraction, and then whatever we get, we divide by 2. This is going to give us 1 over 2, and then 2 minus 1 is 1. We have 1 minus 3, which will become 1 plus 3. That's going to give us 4. Then 0 minus 2, which is 0 plus 2. So we've got 2 here. Now, remember, 1 over 2 here is a scalar. If you use a scalar to multiply a vector, that scalar value will multiply each of the components of the vector. And then you notice that this multiplication is the same as simply doing 1 times this vector and then dividing it by what? 2. So simply, this is equal to, you can say therefore, vector 1 over Rs, okay, that vector is simply equal to 1 over 2. I've divided this one by this 2, then 4 over 2, which of course is 2, and then 2 over 2, which is 1. You know that this vector can still be written as 1 over 2i plus 2j plus k. So, dear friends, this vector, right, is the vector given as 1 over 2 times vector RS. Now, this second part of the question requires that we obtain the unit vector in the direction of this vector. So, we shall be proceeding to determine the unit vector in the direction of this vector. Are you following, right? And how do we get a unit vector? Okay, so the unit vector, I'm going to write it in words. That's given vector divided by the magnitude of that vector. Because that's the formula, you know that. So it's going to be this same vector divided by what? Its magnitude. And this is the vector, so I'm going to put 1, this is 1 over 2. 1 over 2, then 2 and 1. I'm going to divide this vector by its magnitude. And the magnitude is 1 over 2. We're going to square this term. Then plus 2 squared plus 1 squared. Correct. Remember, the unit vector in the direction of any vector. The unit vector in the direction of any given vector is simply the position vector divided by the magnitude of that same vector. That's what I've done here. The numerator here is the position vector we obtained already, 1 over 2, 2 and 1. So we're dividing it by its magnitude. So let us simplify this and see what we are going to get. 1 over 2, 2, 1. So we're dividing this by, this is 4, this is 5. If you work on this, you get 1 over 4. So 1 over 4 plus 5. 1 over 4 plus what? 5. Will simply give you 21 over 4. So this is square root of 21 over 4. Applying the knowledge of surd, this square root can be distributed to the numerator and the what? Denominator. If I do that, the unit vector is going to give us 1 over 2, 2, 1. Then we are dividing this term by 21 is not a perfect square. And so we maintain the square root there, which is square root of 21. Alright, square root of 21 all over. Look at this 4, square root of 4. You know, division law of surd, since it is square root of 21 over 4, you distribute that square root to the numerator and denominator. Square root of 4 will give us 2. Good. So we now have this term, which is the given position vector 1 over 2 RS. Are you following, right? Divided by its magnitude. Now, this is my answer. This is the unit vector in the direction of this vector that we've obtained. Are you following, right? But we can still simplify this further because mathematically, these two can go up. Are you following, right? Division of fractions. Division of fractions. So this is equal to, if these two goes up, watch. If we multiply this term in the numerator, is that okay? So let me just show that. 2 bracket 1 over 2, 2 and then 1. So divided by square root of 21. And so if we do this finally, the unit vector will give us, this is a scalar, so it can multiply each term in the brackets. Are you following, right? 2 times 1 over 2 would give us 1. 2 times 2 will give us 4. 2 times 1 will give us 2. And then we're going to divide it by square root of 21. So this is actually our final answer. This is the unit vector in the direction of the vector 1 over 2 RS. Quite interesting. Alright. I think you enjoyed this calculation. It's just, you know, principle of basic arithmetics. There's nothing that is there. Plus and minus, times, okay? So you can actually cope with it. Make sure you watch the video, okay, over and over again. And of course, the whole concept will sink in. So this is how we are done with addition and subtraction of vectors as one aspect of vector algebra. If you have any question, please, you're free to ask your questions. You know how to send your question across to us. And of course, I'll be there to respond. And if you feel that you are all good, set to go, that you're done with this topic, you got a full explanation of everything I've taught so far in this topic. Below this video lesson, you've got a quiz on algebra of vectors, addition and subtraction. Take it and see how far you can fare in the quiz. In our next class, I'll be teaching you the other concept of vector algebra. We're going to look at multiplication of vectors. Remember, the scalar product as well as what? The cross product of vectors will be the focus of our next class. class. Until then.